All right, continuing with 1.1. Let's just call this video 1.1b as in boy, and we are in the middle of page 7, sets and operations with sets. And we're going to do some definitions. I know that's not one of your most exciting things is the definitions, but let's go through these anyway. The first definition is the word set. A set is just a box of stuff. The definition is actually a set of a collection of objects or things. So if you have a set of marbles, that means you've got a collection of marbles. The objects in the set are called elements or members. So we've got elements or members. Those are the items that are in the set. So if you have a set of marbles, then you have members. The marbles are the members or the elements in that set. Sets are designated with capital letters. So if we're talking about set A, we would call it A, or maybe it's set B, and it would be B. And we also label our elements, the things that are inside the set or within the set, like our marbles. We label those or name those with lowercase letters. So small a, small b, small c, etc. So we also use what are called braces, and most of us aren't very good at making these, especially when you make them fast. The proper way is to make them look like that. It's awful hard with an Apple Pencil to make, but that's what a set symbol looks like using braces. So if I'm talking about the elements that are in set A, I would write capital A equals the set. Let's just say 1, 2, 3, 4. That means that set A has members in it. It has 4 members, and those 4 members are 1, 2, 3, and 4. Another way of writing this is, let's say that I just want to focus on the number 2. And I want to say that 2 is an element of set A. And I can write that as 2. And here's this symbol for element. Looks kind of like an E. Is an element of A. So again, we're taking something that takes longer to say and writing it in a short way. So 2 is an element of A. That means basically that 2 is within the set symbols of A. If I wanted to show, or if I asked the question, is 5 an element of A? No, 5 is not in there. So I would write 5, and then I would write the element symbol and say, no, it's not part of set A. And that's what that would look like. Now, sometimes we want to look at a couple different sets. And when we write those two sets, sometimes one set is inside of another set. So let's say that we have this set of marbles, and we'll call that set A. And we have another set of marbles, but they're all blue, and we're going to call that set B. So even though we have A that has a whole bunch of marbles in it, we're distinguishing the blue marbles by making a separate set, but they're still marbles, so they're going to be inside set A, which is the set of marbles. They're different color, so they're just going to be in their own little set. So all the blue ones are going to be in subset B, but they're going to be within the whole set A because they're still marbles. So it works that way. Let's say A is all the boys in a classroom, and B is all the boys that are blonde-haired in the classroom. So even though they're all in the big circle here because they're boys, because they have blonde hair, they're going to be in this little circle by themselves as part of the big A. So that's called a subset, and there's a symbol for the subset. Just like I said, there's a symbol for element. There's a symbol for subset. And that symbol looks like a letter C. So it looks like that. That is the subset symbol. So if I want to say that B is a subset of the bigger A, I don't have to draw a picture. I don't have to write it out. I just write B is a subset of A. And that means everything in B is also in the larger set A. It's a part of. Okay, so then there's a symbol that looks like this, and maybe you remember this. That means the null set or the empty set. Some people like to make these brackets here and just not put anything in them. That is a set that's empty. It also is called the null set, and the symbol for it is that or that. Most people use this symbol though. That does not mean the same thing as 0. 0 is a number. It's part of a set. So it would be something that would be included in it. So it has to be the null set or the empty set to show that there is nothing in it, not even 0. All right, and then we've got another symbol, and it's called the union symbol. So we've got union, and the symbol for that is easy to remember because it's just, it looks like a U. And when we have a union, that means that we have a set here, and we have a set here. And notice there's some things that are common to both of those sets. But if it's a union, it means that everything in this set and everything in that set is included. So if there are a bunch of numbers in this set and a bunch of letters in this set, the union would be all of the numbers and all of the letters. Not just what's in common, but all of the numbers and all of the letters. So if I had the number 5 here and the letter Z here, these would be in the same set or the same union set because the 5 is in this circle, the Z is in their circle, and it doesn't matter if they share anything. And that symbol, like I say, it looks like the letter U. And let's keep moving along here. If I want to say, for instance, that X is an element of A unions B, that means that if I have an A set and I have a B set and I have an X here, X is a part of that union because as long as it's in A or B, it would be a union. And I would write it as X because it's an element. I would use the element sign. Is an element of A. I could also write it as X is an element of A unions B because A unions B is everything in both A and B, and X is in one or the other. It doesn't matter if they're in both. It just has to be in one or the other. So that is the union. And finally, the last one we'll look at is called intersection. So intersection, it's kind of like an intersection when you're driving a car. And that is a terrible writing of intersection, but an intersection is what is common to both set A and set B. So remember, union meant that it could be in A or B. Intersection says that it has to be in both A and B. So rather than or, A or B, it has to be A and B. So that means an intersection only includes those elements that are common to both A and B. And the symbol for intersection is the upside down U. I can't really think of any really cool way to remember the intersection symbol, but that's what it looks like. It's the upside down U. So let's look at a couple of examples here of this being used. So if I have set A, remember I said it was a capital letter, and I give you the set 1, 3, 5. And I say we've got another set B, and it has the numbers 0, 2, 4. And then I have C, and that has the numbers 1, 2, 3, and let's just say it has all numbers 1, 2, 3, 4, 5, 6, 7, all the way into forever, into infinity. So if I were asking you what A unions B is, union means or. So what numbers are in A or B? So A unions B would be the set 0 from here, 1, 2, 3, 4, 5. So it would be all of the numbers that are in both sets. Now, if 1 occurred in A and 1 occurred in B, you'd only write it one time. But in this case, we have 6 completely different numbers. So that's A union B. Now, if I was asking for A intersects B, I'm asking for AND. What numbers are both in A and B? Nothing is in both A and B, so the answer to that is the null set or the empty set. If I were to ask you what is the intersection of A and C, I'm going to look at my set A and I'm going to look at my set C and find out what's common to both of these. All right, so I have a 1 that's common to both of those, so I'm going to put that here. I have a 3 here, and I have a 3 here, so that's common. I have a 5 here, and this says it goes on forever, so it also would have a 5 there. So that would be the intersection, or what is common to both sets. And then finally, we'll look at B unions C. And again, union means or. Well, I have 0, 2, and 4 in B, and 1, 2, 3, 4 into forever in C. So it has to be in one or the other. Now 0 is in B, but it's not in C, but it doesn't matter. It just has to be in one or the other. C has 1, 2, not bad, 2, 3, 4, and it goes on forever. So we covered all the numbers in B, and we covered all the numbers in C. So that would be the answer. This just shows 3 dots, just shows that it goes on forever. So that's what we're looking at there. And the next video, which will be 1.1C, we'll get into the number line, and then we'll get into product of primes, that kind of thing. Most of these sections will not include so many videos, but what the author did is tried to cram a lot of review information into a few sections, so that's why these are a little bit longer than normal.